Thanks everyone for joining today. Hopefully you're in the right place. This is a talk about generative AI agents and sort of unlocking emergent behavior and LLMs for adaptive workflow automation. I would ask today that you actually bear with me. So I'm currently on vacation, and so I'm using someone else's setup in a B&B right now. So everything's a little bit new to me. So hopefully everything goes well today. So let me just go through our presentation, and then I will have a quick demo at the end, and then we'll leave some time for Q&A. The organizers wanted me to remind everyone that now that we're using Google Meets, if you want to ask questions, in the bottom right-hand corner of your screen, there's a little icon with a triangle, square, and circle. You can click on that and then click on Q&A, and you can type in your questions there. They'll be queued up, and then I can go through those at the end, and some of the team can also help facilitate some of the Q&A. Cool. All right, let's get going. So a little bit about me. For those of y'all that don't know me, my name is Patrick Marlow. I am a staff engineer on the Vertex Applied AI Incubator team at Google. My duties and role on the team essentially are, the LLM lead for agent chaining and just sort of technical lead for all things LLMs and agents and things like that. I have been in the machine learning, NLP, conversational AI space for the better part of 12 years now. Been in software engineering for a long time and hardware engineering before that. At Google, I also contribute to a lot of open source libraries, which we'll actually use one of those libraries today as we're doing the demo. And so we'll talk a little bit more about this as we go along. So I wanted to start off the presentation today to kind of give a brief history of LLM applications. And the reason I'm saying LLM applications is because we're going to talk about sort of the holistic ecosystem of applications, not specifically just models. So in the early days, and I say this with a smile because the early days were really just 18 months ago. It's kind of wild to think about how rapidly and how fast everything has grown in this generative AI space. But in the early days of the generative AI race that we've been in, there were essentially just models. And so what people would do when they were building their applications essentially is, you would have some API endpoint that would call some model. In the early days for Google, this was like Text Bison, or you maybe talk to GPT-3 or some of the early Anthropic models, things like that. You sent a user query in, the model generated some text, and you got some information back from that. And a lot of us, we kind of looked at that and we were like, wow, that was really magical. It responded really great. That's amazing. But as you started to dig deeper into it, you would realize, oh, wait, some of this seems like it was right, but it's not actually right. There was hallucinations. There's no really grounding to it at all. But this was sort of the early days of how we interacted with these models. So then sometime in 2023, this new type of application came about called Retrieval Augmented Generation, or RAG. And this utilized vector databases to sort of ground the models in the responses that they would give. So same kind of thing, you would send a query in, a model would take that, it would do some embeddings, it would match, do semantic search over those embedding space in the vector DB, it would get some relevant, articles back, it would send those to the model, and then the model would sort of reason about, or lightly reason about, which of those things would be the best answer, and then kind of respond back to the user. So this really helped us to minimize hallucinations. We were kind of linking into external knowledge, which was great. We could retrieve data, but there still lacked the ability for our models to actually interact with the outside world in a more direct way. And so what happened after RAG is we started to move into this kind of era, and this is where we're at today with state of the art, is this idea around generative AI agents, or agentic AI, or there's lots of different terms for the way people kind of talk about this. But essentially agents now give us the ability to do reasoning and wrap orchestration around these models and these tools and all the things that we're using, so that we can provide better grounding, better real-time information, and not just reading data, but also like writing back to the outside world, interacting with different systems. And a lot of you today have probably already interacted with agents, whether you've built them or not. If you've played with Gemini on the web or ChatGPT on the web, those are essentially agent applications, right? So they are purpose-built to help users with general knowledge type things. They have some plugins or extensions that you can use to kind of interact with the world. You can even think of things like Alexa, Google Home, those type of assistants as agents in a way as well. A lot of those were built in the pre-generative AI nowadays, so they didn't use LLMs at first. They were just using traditional NLU models and tools to access the outside world. But today we're using a lot more LLMs built into these agent applications so that we can do better reasoning, better orchestration, things like that. So what is a generative AI agent? I kind of gave a little bit of an overview there, but the best way that we like to describe this from like a high level overview is that a generative AI agent is defined as some sort of application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. This is very similar to the way that humans work, right? So we have some goal that we want to achieve, and we observe the things around us, and then we act on those things, and we use the tools available to us. So in the morning, we wake up and we say, I want to make some coffee. And in order to make some coffee, I'm going to go out and I'm going to grind some beans and I'm going to boil some water. I'm going to put all these things together and I'm acting upon the world so I can achieve that goal, which is to get a cup of coffee, right? Agents work in the same way, right? We're kind of thinking through the things that they want to be able to do and then using the tools at their advantage to be able to do those particular tasks. Now, broadly speaking, we have started to see the categorization of agents go into sort of like two main types of categories. You typically see kind of like modality-based agents. You know, people will say things like, I'm building an LLM, a large language model agent, or I'm building a vision agent or a vision language agent that combines these, or some, a robotic, agent application. Or you can also see people sort of say this from the perspective of use cases, right? I've built a gaming agent, a cybersecurity agent, a software development agent, those things like that. I like to break them down into kind of two different sets of categories that are more like applicable to kind of practitioners. And I think about them from the perspective of interaction types. So for example, we find that most people that are working with agents today are in the left-hand category, which is conversational agents. So these are agents where a human is kind of directly interacting with that agent. There's a user query, maybe there's some RAG happening behind the scenes, maybe some tool calls, but it's essentially like a back and forth conversation between a human and this agent that's being built. Now, a lesser known form of agent is called the workflow agent. And in my opinion, this is really where a lot of the real impact and value is in the enterprise today. And so workflow agents are essentially the exact same infrastructure as a conversational agent. The difference is that there's usually no human involved there, or very, very little human involvement. So you could think about this, like a log parsing agent, or an email parsing agent, or a code review agent, or things like that. So there's some trigger that's happening behind the scenes. Think pub sub events or things like that coming into a queue that then triggers an agent to do some tasks, reason about it, and then respond. Now, you might sort of think about that and go like, well, isn't that essentially just, scripting or workflow automation? And the answer to that is yes. We've had workflow automation for many, many years. There's been like RPA vendors that have done a lot of stuff like this. But I think the cool thing of what's happening in the generative AI world with agents is that we're able to now build these workflows without as much code, right? And we can build in some more intelligent reasoning into these workflows without kind of like hard coding all of these different, case statements and things like that. We can let the LLM sort of reason about them and choose the different tools at their disposal to kind of solve those problems in our workflows. And this is really where I see a lot of the impact coming today. So let's talk about some of the foundational components of an agent, and then we're going to get into kind of like how agents work and things like that. So the easiest way to kind of think about this is that agents are kind of broken down into three primary components. You essentially have your model, which is kind of the base language model that you're going to be using. You have some set of tools that you are giving your agent so that it can act and sort of observe the world around it. And then the third one is the reasoning loop. And so sometimes you'll hear this called the orchestration layer, the reasoning engine, the computer. There's many different terms for it. But essentially, this is kind of the heart or the brain of the agent. This is kind of where all the magic happens inside of that agent. Now, kind of breaking down each of those components and talking about them just in a little more detail. So from a model's perspective, this really can be any type of generative language model, large or small, that you want to put inside of this agent. It can also be a fine-tuned or a multimodal model. So if you want to use vision and language agents and combine those things, or models, you can combine those all together. But one of the key things to remember about your model as you're placing it inside of your agent that it's important to think about the training data that went into that model. Now, we're kind of halfway through 2024 at this point. A lot of our models have a ton of training data in them. They're just growing every single day. So I think for the majority of us, we really don't have to worry about this anymore because there's a ton of training data around like most of the use cases that we're already working with. But I think if you are in an industry that is like very niche, or you have a use case that's very niche and there's not necessarily public data available where a model might have been trained on that specific type of thing, then you really have to think about that as you're putting this particular model in your agent. And the reason behind that is because as you're trying to get your agent to accomplish certain tasks, if there's no ground kind of like base knowledge in that model to know anything about that particular industry or that particular task, the agent itself may struggle to do those particular tasks or fire off those particular tools because that training data does not exist. So just something to keep in mind as you're choosing your models for your agents. The next thing to talk about is tools. So remember, tools allow our agents to interact with external data and services. The easiest way to think about this is just API calls, right? So we're giving our agent the ability to make API calls out into the rest of the world. Now, there's lots of different providers that provide different types of tooling that you can connect to your agent. At Google, we essentially like to look at these three types of tools. We have extensions, and we'll talk a little bit more about these in detail. But extensions are essentially fully autonomous, executable endpoints. So we're telling the agent, if I give you an extension, you get to choose when you use that, how you use that, whatever you want to do with it. You don't have to ask me about it. You can just execute that tool. Then you have functions or function calling. And I think there's some more talks later today about function calling as well. But essentially, function calling gives our agent the ability to generate structured output. So you can think JSON outputs. And it also can do really great things like mocking APIs or stubbing API calls out. And then the last of these is data stores or vector databases. I think we're all very familiar with retrieval augmented generation and kind of working with vector DBs. But there's a myriad of other tools that you can also provide to your agents. I've just kind of listed a bunch of random things here at the bottom of the screen. You can build tools like a Google search tool, or you can build a custom tool in Flask and put it on Kubernetes or Cloud Run. And you can even use a human as a tool and tell your agent, hey, if you don't know the answer to this, ask a human, and then it can kind of pause and give you a moment to put input back to the agent so that it can continue its workflow. So many different things that we can do from a tools perspective. So the last of these three pieces is the reasoning loop. Now, this is, again, really one of the bigger cornerstones of how agents work today. And it's because the reasoning loop allows us to do this more kind of iterative, introspective process around how we're going to achieve the goal that we're setting out for our agent and what steps it's going to take to get through that. Now, typically these reasoning loops are built around advanced prompt engineering frameworks. So things like React or chain of thought, tree of thoughts, things like that. But you could also include other simple rule-based calculations, traditional ML algorithms, other probabilistic techniques. You can build really anything you want inside of your reasoning loop. But I think predominantly what we see in the space today is that a lot of these reasoning loops are kind of like out of the box using the React framework, or kind of like some mix of React and chain of thought or tree of thoughts, things like that. Really picking whatever framework works for you is really the thing to go on here. I get a lot of questions every day that people are saying like what's the best practice when I'm building my agent. Unfortunately, there's not like one best practice that fits them all. It's all about like, what use case do you have? What data do you have? What are you trying to accomplish? And you kind of pick and choose the different pieces so that it fits for your particular use case. And one thing to remember is that just because you built an amazing agent for one use case in your organization, it doesn't mean that that same architecture is going to work for your second use case in the same organization. And that's because the data might be different. The data signatures might be different. The structure of everything might be different. So I think what I'm saying here is experiment, try things. Don't just rely on one single way to do things. Try lots of different processes to build your agents out. Okay, so one of the takeaways here around the differences between models and agents, I'll let you read the screen just briefly. I won't go through each of these in order. But the key takeaway is essentially that when we're dealing directly with models, that model inherently has some cutoff date of knowledge, right? So maybe it knows a whole lot and it can generate a lot of really great historical data, but it doesn't have access to real-time data. And this is really where agents excel, right? They have access to real-time data. They have the ability to use tools to get out into the world. And they also have the ability to kind of reason and think about what they're doing. And when I'm saying model, I'm not talking about like, the Gemini app on web browser or Chat GPT on a web browser. Those aren't models. Those are agents, right? Those have the reasoning loops already built in. When I say model, I'm talking about when you're calling the Gemini API directly without anything else, just sort of vanilla API calls, or the GPT API call, the OpenAI models directly. Like those are just vanilla. There's no other infrastructure wrapped around it. You're just getting a response back from it. So that's the difference between models and agents. It's sort of like what data is inherently available to them, and versus kind of what tools they can use out in the outside world. Okay, let's think about sort of talk about briefly the basic operations of an agent so we can kind of understand what's happening under the hood. So remember, we've got kind of our three components of the agent. And so you can imagine on the left side, we have either a user interacting with this agent system, or maybe there's some event, from a pub sub, queue coming into this agent system. Some magic happens in the middle, and then we get a response back. So what that might look like using a React framework with React agents is that I might say something like, I want to book a flight from Austin to Zurich. Now, in the internals of that agent, what's going to happen is it's going to go through this sort of React reason and action loop, and it's going to kind of look at each of the pieces and think through them. So, question, I want to book a flight. I should think about this. I should search for flights. Okay, I have these tools that are available to me. Let me pick one of those tools. I'll pick the flights tool. And in order to use that flights tool, I have to give it some inputs. So I'm going to give it flights from Austin to Zurich. Now that tool is going to call an API endpoint, and it's going to return some data back to me. And now I'm going to observe what that data was. Okay, the flight tool returned many options. I should go ahead and present these back to the user. And then in natural language, here are some flights, from Austin to Zurich. Which one would you like to choose? Now that is just one loop through that sort of React process. And that's a very clean loop, right? Like it did the reasoning all in one step, and it didn't have to think about anything else. But inside of that green box, that loop can happen n number of times, right? So it could iterate inside of there and say, oh, the Flights API didn't give me really good results. Let me change my inputs and call it again and filter the results down. And this is all without the user having to say anything else. This is the agent, the reasoning loop, sort of figuring out, okay, I need to make a better, query to the tool so that I can get better information back from from the endpoints and give that back to the user. So this is a basic interaction for the user. So let's talk through the tools real quickly, and we'll actually get into RAG as part of the tools for agents, right? So the first tool I want to talk about is extensions. So we'll use the example of the Google Flights API again. So imagine you're building your agent, and you know that you want to connect it to the Google Flights API, but you're not really sure how you're going to glue these two things together. So the simplest way to be able to do this is build out an extension. So it's just a type of tool that allows the agent to kind of facilitate an API call to your API endpoint. Now, extensions do three things. They essentially describe the when, the how, and the what to expect with that API back to the agent. So essentially, the when is when the user wants to search for flights, you can use this particular tool called Get Flights. And how you use this tool is that you're going to provide argument number 1 and argument number 2, and maybe some other optional arguments. And then when that tool returns, this is the payload that you should expect. So essentially, we're defining the interface between the agent that doesn't speak API and the API that doesn't speak agent. And so we're kind of connecting those two things together in the middle using this concept called an extension. Now with extensions, primarily what we see today is that these are built on top of the Open API specification. And I want to be clear that Open API is not the same as Open AI, two different, completely different things. The Open API, if you're familiar with Swagger, the Swagger UI, you can essentially build out the specifications for your API endpoints using YAML or JSON to just describe what that API looks like and how a human or a machine should interact with that API. Now you can build these extensions in pretty much anything you want, right? So if you want to build them in serverless environments like Cloud Run or Cloud Functions or AWS Lambdas, you can do that. You can build them in, kind of as a Flask endpoint. You can deploy them on Kubernetes or on compute. Like, it really doesn't matter how you build your extension. The key takeaway about extensions is that the agent has full autonomy to make that API call at any time that it wants. It doesn't have to ask you if it needs to make that API call. It just knows that it has that available to it, and it's going to make that API call to solve the goal that you've given it. Okay, now let's talk about functions. A lot of you may be familiar with the concept of function calling. And so this is essentially function calling, but I'm going to talk about one specific use case with function calling that you can particularly do. So this is something that we see a lot in sort of like enterprise environments, is that you might have, maybe a central kind of area where you're building your agent, and you've thought about building your extension in sort of like project number one, which is like general access. And then you have some API endpoint that is super secret and it's secure and nobody has access to it in the enterprise. And essentially you want your agent to call over to it. Maybe it's secure data in a BigQuery table that's in a completely different GCP project. Maybe it's something that only the security team has access to because it's security logs or things like that. Now, if you tried to use an extension, maybe your security team says, no, you can't have direct access to this. So how can we actually connect these things together and allow our agent to use them? We can use a concept called functions or function calling. Now, essentially, functions are a subset of extensions. So functions define the when and the how, but they don't ever define the what to expect. And the reason behind that is because the function is not actually making the API call. The function is mocking the API call, right? It's saying when the user wants to search for flights, I'm going to use this get flights function. And what I'm going to do is sort of build the payload of how I would have used that API if I had the ability to do that. So I'm going to build the function call payload, and I'm going to hand that back to the agent. And I'm going to tell the agent, I don't really know what to do with this, but here you go. Here's the payload. And what the agent can do is kind of hand that payload upstream to the user, right? So that user in this scenario might be some maybe custom UI that we've built, or a middleware or a proxy server or something that maybe is privileged and has the ability to make that API call to the super secret API. And so essentially what you're doing is you're relying on the agent and the function to kind of play a game of Mad Libs, right? Fill in the blanks for my function so I know what I should be calling, then give it upstream to the thing that has privilege so that it can make that call, and then get the response, and then give that back to the agent. So this allows you to kind of stub out API calls and get a lot of this, kind of information back to the agent, even though the agent can't directly access this. Now, to be clear, this is just one way that you can use function calling. Function calling is really amazing, and it can be used in a myriad of different ways. So this is just something to think about as far as like, one different use case. A lot of times I like to do this side by side to kind of just show users what's the difference between extensions and functions. So at the top, you have extensions. Essentially, you are giving the agent full control about when to call this extension. It has full access to execute this at any time. It doesn't need any other proxy or middle layer or user involved. Whereas with functions, the function cannot actually execute that API endpoint. It's going to hand that information upstream to either the developer or a proxy layer or middleware, something like that, and that is going to facilitate that particular call. Now, the last tool to talk about is data stores. Again, vector databases is essentially what we're talking about. I won't go into the depths here. We had some really amazing presentation earlier from Zane. We're going to have some other presenters over the next couple of days talk about vector DBs and RAG. I think everyone really knows this, but just a super brief overview. With RAG, essentially what we're doing is we're taking private documents, structured data, website data. We're creating embeddings. We're storing it in a vector database. We're allowing users to then send a query. That query does a semantic search and match. It finds the best source, and then it returns some information back to us. So we can use this kind of retrieval augmented generation, setup as a tool to give to an agent. So that if you've got a RAG pipeline that you're already using, you can essentially just encapsulate that in a tool and give that to your agent and say, like, here, use this anytime you need to search the database or search the website or search private documents. I was reading a blog the other day, and I saw this really great quote inside the blog that said, everyone's talking about retrieval augmented generation, but not everyone actually has any documents that are worth retrieving. And I kind of laughed at that because it's like, I think there's a lot of hype around, the Gen AI space right now, and everyone's talking about like, oh, I built this cool RAG pipeline and all these different things. But when you go and look at the data they're retrieving, it's actually garbage, right? And that, I think it's because a lot of companies haven't really thought about their data posture, right? They haven't thought about like data pipelines, data engineering, data cleanliness, stuff like that, right? And so I think it's important to remember that these systems that we're building, whether it's a RAG pipeline or an LLM application or an agent application, they're still garbage in, garbage out. That hasn't changed. So if you're feeding them terrible data, you're going to get terrible search results, and you're going to get terrible agent stuff on the back end. So just think about that as you're building the ecosystem around your application, because it is really important to have like high quality information that you're feeding into your agents. Okay, so a couple sample architectures, and then we're going to get into the demo really quick and hopefully have some time for Q&A. So here is one example of a simple sample architecture that you might build for an agent. So you can see here, essentially in the top left corner, I have something like a custom UI or a custom interface for my agent. My agent sits behind that UI, so API calls from the UI are going to my agent. My agent is working with the model and the tools and few shot examples, all that behind the scenes. And then that is connected to either function calls or data stores or extensions. And depending on which of those particular tools I'm using, it might go through different execution loops. It might go through the extension execution loop, which is autonomous, or the function execution loop, which kind of hands some work back to my custom UI, and the UI might call other API endpoints from there. So the last kind of thing to talk about before we get into the demo is some more advanced techniques around multi-agent architecture and sort of advanced operations. So predominantly, we're seeing two large architectures form around how agents are built, kind of out in the wild and in production. The first of these is essentially called a collaborative multi-agent architecture. Now, in collaborative architectures, the way this works is look at each of these, yellow boxes on the screen, and imagine each of those as having the, the model, the reasoning loop, and the tools built inside of them. Now, in the middle, what we have is essentially a messaging queue. Again, think PubSub, Kafka, things like that, RabbitMQ. A message from the user or an event will hit that queue, and then some bidding essentially occurs. So a bidding between agent A and B and C and D, they all kind of say like, okay, who can solve this, particular question the best? And maybe agent A says, I have a very high confidence that I can solve it. I will take that request, and that will go to agent A, and it will go through its introspective reasoning process and do whatever it needs to do. And then when it's done, it will spit out a message back to the queue. And maybe that message says like return to user, and it responds back to the user. Or maybe the message says, this is up for bid again. I don't know who solves this next. Or maybe the message says, agent D, this one's for you. I'm passing it back over to you. And in this way, you sort of have this centralized kind of like hub and spoke where you're using a messaging queue to kind of facilitate information to and from all of these different agents, and then kind of funnel all of this information back to the user. Now, the other type of architecture that we see is a kind of like a top-down or a supervisory architecture. So essentially what this does is it uses kind of an orchestration or a steering agent at the top level to facilitate those interactions. So instead of a messaging queue, every message comes into some top-level agent. You can think of it like a switchboard operator. So, hey, I want to book some flights. That orchestration agent looks at that and says like, oh, okay, I need to go to agent A, which is my flight booking agent. And then it might return back. Or maybe after the flight is booked, it might go to agent D, and agent D might pass over to C. And all of these agents can be interconnected in a myriad of ways. But this is, I think, one of the architectures that we see most used, especially around sort of like chat applications, because this is sort of like a, again, it's kind of the same way we might facilitate conversations as humans. Okay, I'm going to leave this up here for about 15 seconds while I take a sip of coffee, and then I'm gonna flip over to the demo. So take a screenshot of this, take a picture of it. Great resources to kind of follow up on later. There's not a whole lot I can fit inside of a 30-minute session. So I would say if you're really, really interested in a longer session that I've done, that last one on the screen called Production Scaling of Agents, it's about an hour and a half long about talking how to scale agents out for production. I highly encourage you to go watch that. It's on YouTube. And I'll be 1 second. Okay, so let's go ahead and do this. Let's go ahead and jump into the demo. I am going to stop sharing my screen real quick and flip my screen around so that I can actually see the code that I'm doing. I saw a question on the screen that said, is there a latency trade-off between one big agent versus multiple agents? I think it really depends, honestly, on kind of the agent architectures that you're building out, and a lot of times sort of the providers that you might be using. So, sometimes I think, calling agents in chains can create a lot more latency. And so actually the video that I was just talking about to read, like we talk about that in depth. We talk about the trade-offs between latency and accuracy and things like that. So I think a lot of people want to build sometimes one giant agent because it has all of the information in it, but then that means that you're consuming a ton of tokens with every single call. And that means as you add few shot examples, those examples grow really large, and it's kind of harder for the agent to choose the exact examples. Whereas if you break it down into multiple agents, kind of like we're looking at in this sort of like, supervisory top-down thing, you may incur a little bit more latency as these things are chaining together, but the accuracy of each of those individual agents is a lot more accurate versus kind of the really large agent. So lots of trade-offs everywhere. Definitely go watch the video that I sent over. Okay, so really quickly, what I'm going to do is kind of show a quick demonstration. I'm going to show it in code, and I'm also going to show it in the UI, so you can take a look at it. So we're going to build like a very simple top-down supervisory type agent. One of the libraries that I'm using here, and I guess I should zoom in just a little bit, I'm using the Scrappy library. So this is an open source library that I manage here at Google. It interacts with the Vertex Agent Builder SDK. It's just a really simple way to be able to build agents. And so what we're going to do is we're going to build a brand new agent. And I hope that I actually deleted this other agent, but we'll just go ahead and start it from here. So I'm going to run this cell. Hopefully I deleted this agent so it actually runs. Okay, cool. So we're just going to import Scrappy. We're going to instantiate our class, and we're just going to give it a couple of really basic bits of information. And now we have an agent built. So this link is going to go to the UI. I'm going to come back to it later, but I just want to show you that right away we have a brand new agent built. And so what I'm going to do is build out a brand new session, and I'm just going to send a few queries to it right away. So send these 2 queries to it. Hey, how are you? And what kind of models do you have? And you can see here the user, responds, I'm doing well. How can I help you today? We have a variety of models to choose from. What type of vehicle are you interested in? Now, this is an intentionally ambiguous question, right? I'm doing this on purpose because I want to show you how we can sort of fine tune this agent to do more for us over time. So if I take a look at sort of the default agent that was built for this, I'm going to go ahead and run these few sets of code. When I look at this default agent, you can see that there's a default goal and there's no sets of instructions here, right? And so what we're going to do is just give it some really simple instructions. I'm actually going to tell us that this is a friendly Tesla Service Center agent, and the job of the agent is to help users book appointments and answer questions. And then here are the instructions. So if I click on that, I'm going to send that information. It's updating the agent live. And then I'm going to go ahead and test my agent one more time. And I'm going to use the exact same query. I'm going to say, what kind of models do you have? And you can see this time that it's actually, changed up, right? So we have a variety of models to choose from, including the model S, 3, X, and Y. So now that it knows that it's a Tesla agent, it's kind of using that context to kind of respond in the way that a Tesla agent might do. So the last thing that we want to do is actually create a few tools. Now, I talked about earlier around the types of tools that we can use. So I'm going to create some extensions, which I've already predefined here. I have a get weather extension and a places search extension that's using the Google Places API. So I'm just going to click on that, and I'm going to go ahead and create these tools. And that's just going to show me that these tools were created. Now, what I'm going to do in the interest of time is I'm going to jump over to the UI real quick. And then one of the things I really want to point out about this is that, we've put the few buttons in this collab really quickly, but the amazing thing about this is that this is all backed by Google scalable production level, production grade, infrastructure behind the scenes. So if I wanted to release this agent right now to the public and start serving 100,000, 1 million users, this is already ready to go. There's nothing else that I need to do. There's an API that I can hook in, and so I can just do that right away. Now, if you've built agents with LangChain, if you've built agents with Reasoning Engine, you know that when you build your agents, just building it in the collab is one part, and then you actually have to productionalize it, right? Like you have to serve it on infrastructure that's scalable. You don't have to worry about any of that here. Like it's already done for you, right? And so, in this interface, I can already start interacting with it. What kind of models do you have? And you'll see I'm going to get kind of the same type of response. from here. Now I've given it, the instructions and the goals here. And on the left-hand side, if I take a look, we can see that our tools were built over here. Now, if I were to ask it a question like, where can I get my car fixed in Boulder, Colorado? It's probably going to respond back with something that is likely a hallucination. So if just doing live demos are always fun because I have no idea what it's going to say. So I'm going to take that address that it gave me, and I'm actually going to go look at Google Maps and see like what this address is. And so if we take a look at this address, you can see as it loads on the screen that this is just some random street corner in Boulder, Colorado, right? Definitely not a Tesla service center, right? And the reason that this is happening, obviously, is like what I talked about in the presentation earlier, is that this isn't grounded in any way. We're just talking to the model right now. We actually haven't attached a tool to it. I've built the tools, but I haven't attached them to the model yet or to the agent. And so what I'm going to do is just add one additional instruction here. So I'm going to say use, instead of doing this in code, I'll just do it right here in the interface. So use tool, place a search to find information about Tesla service centers in a given city. And I'll hit save. And fingers crossed, live demos. We'll see how this goes. So I'll replay this conversation. What kind of models do you have? Blah, blah, blah. Okay, cool. Where can I get my car fixed in Boulder, Colorado? Now, this time it actually calls the tool. If we take a look at that tool, we can see that we're getting like real information back. Tesla Service Center, Boulder. You can see that I'm getting real addresses from the Google Places API. And now we can see those results here. And so if I just go ahead and grab one of these addresses, so this is in Superior, Colorado, just down the road. So we'll just double check to make sure that this is actually some sort of Tesla service center. I don't know what's, no pictures there. Let's take a look at the next one. Let's see. That one says it's a Tesla service center too. I like to just verify these things. Sometimes even Google Maps doesn't always have all of the exact information there. Okay, so this is one on Lincoln Avenue. We take a look there. There's the Tesla service center. So, real-time information, non-hallucinated information from the Google Places API. And we were able to do all of this in just a few minutes, right? Just kind of like doing some of this in code, flipping over to the UI, doing some of this in the UI. And again, I think one of the key takeaways here is that you can do a lot of this in code if you want to, but also if you have non-technical users that just want to write prompts and build few-shot examples, the UI here is available for you to do that as well. So you can kind of flip back and forth between these things. So with that, that's really the end of my presentation. I think I've kind of run over time here. What I'm going to do is bring the slides back up just a little bit, so I'll pull this back up for you guys here. So thanks everyone for joining today. I don't know if I have time to answer a few questions. Let me see if I can run through a couple of these really quickly. Let me see. Okay, so one of the questions was, is RAG considered a simple case of an agent? I would say that RAG by itself as a pipeline could be considered a simple agent. Depending on the architecture of your RAG pipeline, you may have reasoning built into that pipeline. And so if you do, then yes, you can consider it as an agent, but also it can sort of be a turtles all the way down type thing, right? So you can have a RAG pipeline that has reasoning inside of it. You could wrap a tool around that and give that to a completely different agent. So your agent has a reasoning layer that uses RAG that also has a reasoning layer. So you can do this, again, it's very meta all the way down. Another question was, how do we get Gemini connected to BigQuery? So that's, I think, a larger architecture question. So Gemini by itself as a model, obviously doesn't directly connect to BigQuery. So what you would have to do is build like an extension or a function call as an intermediary to facilitate those transactions between the model and BigQuery. We talked about the latency trade-off question. Let's see, are there use cases where one type of agent architecture like top-down or collaborative work better than another? That's a great question. So I think, again, if you're building what we see most people building sort of like a chat application, I think the top-down supervisory type one works really well, because if you're familiar with building chat agents or kind of conversational AI agents, there's this concept of sort of like intent detection, and that top-down supervisory agent does a really great job of sort of like steering, right? So it does intent detection and then can like steer the user wherever you need to go from there. I think when you're doing things that are more sort of like autonomous, so like event-driven, like log analysis, code analysis, things like that. The sort of message queue architecture works a lot better because it's not just single stream. You can just feed lots of stuff into the queue, and the agents can kind of pick them up asynchronously, and they don't have to wait for each other, right? So it really kind of depends on what the end application is that you're going to be using as to which architecture you might pick. Let's see, curious if I can have a link to the demo to run it by myself. Yes. So again, the resources here on the screen, take a screenshot here. The link in the middle will take you to the Scrappy repo on GitHub that has the notebook. You can run the notebook live, and then you can start kind of building things from there as you'd like. Is Scrappy library compatible with Crew AI? It is not at this time. Scrappy was built specifically to run on top of Dialogflow CX and on top of the Vertex AI agent builder. And so that's what it's available for right now. But maybe we could think about that in the future. Is Google Agent Builder publicly available now? It is publicly available. I don't think it's GA yet, but it should be going GA in the next quarter or so. Does the Agent Console have a free tier? I don't think that the Agent Console itself has a free tier, but if you sign up with GCP, typically you get some sort of credits to start with, and you can start interacting with the Agent Console with those credits. How is the agent framework related to Dialogflow? That's a great question. The agent framework essentially is, you can think of it as, kind of the next successor to Dialogflow. So if you're familiar with the Google products, we had Dialogflow ES a long time ago, then we had Dialogflow CX. And so Agent Builder is basically just the new sort of iteration of that product in the generative AI world. And so you can interact with these things. You can use Agent Builder to interact with Dialogflow CX and vice versa. And so these things can be compatible with one another. Cool. All right. I think that's all the questions. Thanks for sticking around. And thank you, everyone, for joining the talk today. Feel free to connect with me on LinkedIn. And hopefully you learn a lot at TMLS this week. Take care.